Graphing absolute value functions. You recognize the function because it has the absolute value sign. Now you need to recall that when you graph an absolute value, remember the V should remind you that the graph is going to make a V, whether it's right side up or upside down. The most important part of graphing the absolute value function is going to be finding that vertex point. So this is how you do that. To find your vertex, you're going to take just what is inside the absolute value and you're going to set that equal to 0. So I'm going to say x plus 6 is equal to 0, and I'm going to solve for x. Subtract 6 from each side, so x is equal to negative 6. Now that is the x coordinate of my vertex. So how do you find the y coordinate? We're going to take this number back up here and use the whole function, and I'm going to fill it in with x. Instead of f of x, I'm going to put y, and I'm going to have absolute value of x plus 6, and I'm going to fill in with negative 6. So if I have y is equal to absolute value of negative 6 plus 6, then y is equal to 0. So this is my vertex point, and I can go ahead and graph that. Come over 6, 1, 2, 3, 4, 5, 6, and 0. So I've got a point right here. Now, I need to find my two legs of my vertex. If it's positive out here, then your graph is going to go up. If it's negative out there, then it's going to go down. So that's the first thing. This one is going to go up. So let me find a couple of points on either side. Look at where your vertex is. What are a couple of numbers to the right? Well, I could use, if this is negative 6, I could use negative 4 and negative 2. So let's graph those, negative 4, negative 2. And then what are a couple of points to the right? Well, how about negative 8 and negative 10? Now once I find my y coordinates for all of these, I'm going to have a pretty decent, representation of the graph. So let's just start filling in and solving. I'm going to put negative 4 in. Negative 4 plus 6 is 2. The absolute value of 2 is 2. When I fill in negative 2, I've got the absolute value of negative 2 plus 6, which is 4. Y is equal to 4. Okay, when I fill in negative 8, I've got y is equal to the absolute value of negative 8 plus 6. Negative 8 plus 6 is negative 2, and the absolute value of negative 2 is positive 2. Now you should expect to start seeing your y values repeat because that's what's going to make the V shape. And then if I put negative 10 in here, negative 10 plus 6 is negative 4, and the absolute value of negative 4 is positive 4. So let's plot these points real quick and we'll see what our graph looks like. Alright, here was my vertex. Now I'm going to go negative 4 and up 2, and negative 2 and up 4. There's the first leg of it. Then I'm going to go negative 8 and up 2, and negative 10 and up 4. And there's the graph of your absolute value. Let's look at one more. Now let's graph f of x is equal to negative absolute value of 2x plus 7. Now when you see the negative sign in front of your absolute value, that's what lets you know that this is going to make an upside down V. Okay, so our vertex is going to be the high point. The most important point is finding that vertex. So to find a vertex, you take just what is inside the absolute value, just the 2x. You're not worried about anything that's added to or multiplied by outside the absolute value. All you want is what's inside. So I'm going to take 2x equals 0. This is going to lead me to x is equal to 0. And then let's make an XY chart. And typically when I do these, I put my vertex kind of in the middle. So here's where 0 is going to go. Now every ordered pair has 2 points, an x and a y, and you just found the x. Now let's go find the y. You do that by taking this number back up here to your original equation, and instead of f of x, I'm going to put y. So now I have -2. I'm going to insert the 0 for x, and then I'm going to solve. Y is equal to, now 2 times 0 is 0, and -0 is just 0, so my y is equal to 7, okay? So let's come over here and plot this vertex point. You're going to go to the left, you're going to go 0 to the right or left, and up 7. And that's going to be a dot right there. Now that was the hard one. For these other points, you get to pick whatever x you want. The first time to find that vertex, first we had to use 0, or we let it equal to 0 to find the x, and then we had to plug that in to find the y. But this time, we just get to pick any numbers we want to. Let's pick some that are kind of close to the point that we already have. I have one here right on the axis, so let me pick a point at, say, +2 and +4. Then let's go the other direction and get -2, -4. That should give me something on either side of my vertex. All right, now for each one, we're just going to fill it in and solve. We already have x. This time we're only looking for y. So I'm going to do y equals, let's take the first one, negative absolute value of 2 times 2 plus 7. 2 times 2 is 4. The negative, the absolute value of 4 is -4. -4 plus 7 is 3. All right, let's do another one. Now let's do the point at x equals 4. So I've got y is equal to negative absolute value 2 times 4 plus 7. 2 times 4 is 8. Negative of the absolute value of 8 is -8. So -8 plus 7 is -1. Okay? Now let's look at the next two. If I plug -2 in, I've got negative absolute value of 2 times -2 plus 7. 2 times -2 is -4. The absolute value of -4 is 4, but then I've got this negative sign. So my final answer there is going to be -4 plus 7, which is 3. And once again, you should expect to see some of these numbers repeat. So when I plug in -4, that's going to be negative absolute value of 2 times -4 plus 7. 2 times -4 is -8. The absolute value of -8 is +8, and then -8 plus 7 is -1. Okay? Now let's plot these points and see if we get a V. So I've got over 2 and up 3, over 2, up 3, and then I've got over 4 and down 1. Okay. Now I've got backwards 2 and up 3, and then I'm going to go over -4 and down 1. Okay. So that's what it's going to look like. Now this time let's go ahead and tell what the domain and the range are. So your domain is the set of numbers on the x-axis. Remember, your domain is your x's. What are the possible numbers on the x-axis where I could find a coordinate for this graph? Well, since it's going to keep on going out, it doesn't matter how far down the x-axis go, I'm going to find a point that matches on this graph. So my domain is the set of real numbers, everything. Now, my range is the set of y numbers. So look, this graph stops right here. Here's your y-axis going up. So when I go up here to 1, 2, 3, 4, 5, 6, 7, that's as high as it's ever going to go. This graph is never going to go past 7. So where is it? It's at all the numbers less than or equal to 7. So my range, and we write it like this, y such that y is less than or equal to 7. Because it starts at 7 and it goes all the way down to all the numbers less than. Okay? So y such that y is less than or equal to 7.